Hey folks, today we're going to talk about parallel circuits and general properties of parallel circuits. So first thing you should do is you should copy this circuit. So pause the video and copy this circuit, and when you're done, hit play. All right, hopefully you're back. All right, so some general things as review that we've already discussed. We are going to be using Ohm's law a lot in this circuit. So reminder, Ohm's law is V equals IR, or if you rearrange that, I equals V over R. Okay. Other things to consider. Voltage is like height. So what we're going to do is we're going to consider this to be like a ski slope, and you're going to compare voltage to height. The current, well, that is a skier's. I think it's just one eye. That's just the skiers. They're going to go around your ski slope. And then the resistors, those are like the hills or the runs that the skiers ski down. And finally, the battery, or if you had a power supply, that'd be the same. That's like the chairlift. That gives the skiers height, and then they ski back down. Okay. Now I do have a little simulation of this. So this is a FET circuit. Uses the same resistors that you just copied. I'm going to turn all the current on, and imagine these little red arrows are the skiers. Okay, that's the current, but pretend they're the skiers. So the skiers get lifted up the chairlift, and they get to here, and they have a choice. Some go down this first run. Some keep going along this way. Some go down this run. The rest of them keep going this way, and they go around this run. And then they all return back to the chairlift. They've all lost that same height. They all return to the chairlift and get raised up a certain voltage again, and the cycle repeats. Okay. Now, some notes about, hopefully you've done a lab on this, but some notes that, as a reminder, what the things you learned about for parallel circuits. So the battery voltage is 12 volts, and I'll test that just to make sure. So you see our little voltmeter says 12 volts. If you look at any of the other resistors in the circuit, they also have a voltage of 12 volts. In other words, voltage is the same for all the resistors that are in parallel to each other. And if you think of this as being like skiers, well, if the chairlift lifts you up 12 feet, no matter which run you go down, you're going to fall 12 feet to get back to the bottom of the chairlift. Okay? So for parallel circuits, V is the same everywhere, for everything that's parallel to each other. Okay. What about the currents? What do we talk about with currents? Okay. Well, let's go back to our circuit. Okay, I'll get rid of the voltmeter for now. Okay. What I want you to notice is when we measured each current, so the current through this resistor is 3, the current through that resistor is 1, and the current through that resistor is 1.5. Well, if you take 3 plus 1 plus 1.5, you get the total current, which is 5.5. In other words, if 5.5 amps comes off the battery, these three have to take that 5.5 amps and bring it back down to here. So again, remember, current is things. It's charges flowing through your circuit. So if you have 5.5 of them come off the battery, 5.5 have to go down. If there were skiers, now hopefully you wouldn't have 5.5 skiers, but if you did, if 5.5 skiers go up the chairlift, then 5.5 skiers have to come down somewhere along your ski resort back to the bottom of the chairlift. So the currents add up. So how we're going to write that as a math is we're going to write I total is equal to I1 plus I2 plus I3. Okay. Now, what about total resistance? So in the lab you learned that when resistance actually goes down when you add resistors in parallel. And let me show you that. So I'm going to shut off all of our currents, okay? And we're just going to turn this last one on. So if I have a single 12-volt battery and a single 8-ohm resistor, the current is 12 divided by 8. That's V over V over R, which is I. That's 1.5 amps, okay? If I add another resistor in parallel, so I'll add this guy over here. Boom. Now I want you to notice what happens to our total current leaving the battery. So here's that resistor off, Here's that resistor on. This current clearly increased, okay? Well, looking at Ohm's law, if current goes up and our voltage doesn't change, it's still 12, okay? If current goes up, R has to go down to keep voltage at 12, okay? So it turns out that when you add resistors in parallel, you actually decrease the overall resistance of your circuit, and therefore you increase the amount of current of your circuit. A couple other ways to think of that is if you have a ski resort and you only have one hill to go down, you're only going to have a few skiers. If you add a second hill to go down, you can have more skiers on your resort. If you add a third hill to go down, you can have even more skiers skiing on your resort. So you're increasing the number of paths, which means you're decreasing the resistance. You're making it easier for skiers to ski down your slope because now you've got 3 of them instead of 1, and you get a choice. Another way to think of that is imagine that this is a room up here, and I say you have to leave the room. Well, if I only open one door, we're going to go out, but it's going to be kind of slow. But if there are 3 doors next to each other, you're going to be able to get out of the room quicker. People can leave more quickly, so that's more paths, easier to get out, less resistance, more current. Okay, so it's another way to think of parallel resistors. Okay, now to find total resistance is actually a formula. So I, from Ohm's law, is V over R. So in this equation here, I'm going to replace each I with the V over R. So V total over, we're going to call this the equivalent resistance of the circuit, the total resistance. That's going to be V1 over R1 plus V2 over R2 plus V3 over R3. However, what do we say about the voltages? They're all the same. So we can cancel those out. And so you get the following equation. 1 over the total resistance of your circuit is 1 over R1 plus 1 over R2 plus 1 over R3. Okay? Now, you have to do the 1 over stuff. You can't just skip it, unfortunately. Also mathematically, I'm going to show you that when you add resistors in parallel, the total resistance goes down. So let's just say, for example, that you had 2 resistors and they were each 4 ohms. So you got 2 4 ohms resistors and you put them in parallel. Well, if I use our formula here, you get 1 over Req equals 1 over 4 plus 1 over 4. Well, what does that equal? Well, that equals 2 over 4, which is 1/2. Okay? You flip that over to get Req, and Req is 2 ohms. Well, how does 2 compare to each individual resistor? It's less. So by adding resistors in parallel, you actually lower resistance. One more note. In your household, circuits are connected in parallel. So for instance, imagine that this is a hairdryer, a lamp, and a toaster. Okay? If you turn on the toaster, and the 2 things are off, that's fine. If you turn on the lamp, nothing happens to the toaster. And if you turn on the hairdryer, nothing happens to the toaster or to the lamp. So you can turn things off and on, and those won't affect the other items in your circuit. So your household circuits are actually wired up in parallel. Oh, and I'll mention one more thing about that current. If we look right here at this junction, we call this a junction right here where wires meet, okay? The total current going into that junction is 5.5. The total current coming out of that junction also has to be 5.5. Let's check it out. This current is 3. This current is 2.5. If you add 3 plus 2.5, you get 5. The same thing with skiers. If you had 5.5 skiers entering that area, 5.5 have to eventually leave. So there you go. All right, the next video will actually do some math with this and try it out. Hope that was helpful, and thank you very much.